So this example is fx 2x squared plus 1. Gx is 2x, 2 minus 3x. And we want to do the composite g into f. So we always put this one inside f. You can see it's actually sitting inside fx, isn't it? So this here is actually written in here. See, fgx, which means you replace this function with x in the function as well. So in that case, g goes into f. So you would have 2 minus 3x squared plus 1. Okay, so this function, g, is put into f wherever you see x, like that. And then you would expand this. You can do that yourself if you want. Expand and simplify. Okay, again, and if you do the opposite, you may be putting g fx. You're putting the f function inside the g function, like that. So get your f function and put your f function, which is this, put that inside g. So that would go here. It would go in where you see x. So that would be 2 minus 3, 2x squared plus 1. So 2 minus 3 at 2x squared plus 1. And you would expand that and simplify it. Okay, that one there. And also, you may also have, remember, g into g or f into f. And that would be written f2. It's not square, so you don't square the function. What that means is put f into itself. So fx, like that, you see? So put f into itself. In that case, you'd be putting 2x squared plus 1 into itself. So 2x squared plus 1 plus 1. See how and there's a square there, right? So 2x squared plus 1 and 2x squared plus 1 is inside, and you simplify that as well. Okay, so that's what we did the last lesson. And if you get f3, if I want f3 x, it means f2x. So take what you found here and put it back into the original function, back into here. Okay, you may see f3, f4, f5 like that. So we'll talk about that when you see it. So go to question 3 here. Okay, I'm going to give you time to work and I'll come back later and see how you're going. So look at question 3. So we want to find the composite FOG. So you're putting G function into the F function. So take your G function, which is here, and put that into your F function wherever you see X. So that would go in there. So you would have this in here. So that would be 3 minus X squared plus 1. And then you simplify that, okay? So can you do question 3? Just do question 3. I'll give you a couple of minutes and I'll be quiet. And then in a couple of minutes, we'll go through the answer. And you have your answer key in the back, so you can also check there. Right, so I'll give you, say, 2 minutes for this question. Then we'll go bit by bit. If you're very fast, you go and do some other questions. But the slowest student should be working with me here, all right? So go and do that for a couple of minutes to 11:40, 11:41. Okay. Okay, for question B, I'll get my pen to work. There it is. Okay, so in this case, we're putting F into G, aren't we? So take your F function and put that into G here. So you're going to get 3 minus x squared plus 1. So 3 minus x squared minus 1. 3 minus 1 is 2. 2 minus x squared. Yes or no? Okay. That one. 2 minus x squared. There it is. For that one there. Now in question C, we need to find x. Find x given that g of x equals fx. So g of f, well, we already did this already. So it's 2 minus x squared equals fx. And fx was x squared plus 1, right? And so we end up with a quadratic equation here. So x squared, I'll put this x squared on this side. So you'll get 2x squared and put the 1 on that side. It would be 2 minus 1, which is 1. So 2x x squared. So x squared equals a half. And so x will be plus or minus the square root of a half, which is plus or minus 1 on root 2, which is the same as root 2 on 2. We'll talk more about surds later, but you should get something like that, and plus or minus 2. Like that. Plus or minus root 2 on 2 or 1 on root 2. So remember, when you're splitting something like this, if you don't have a calculator, if you've got A on B, we can split this as root A on root B. That's what I've done here. So root 1 on root 2, and root 1 is 1 here. Okay, so that's your answer for that one. So that's, check your answer key, it should be in there. So if you look at this one here, we talked a bit about this kind of thing yesterday. We're given the composite already. And you should be able to see there are 2 functions here. And you should be able to see x minus 3 is inside another function. All right, I'll let you do these couple here for a couple of minutes, see how you go with them. 4 and 5. So do 4 and 5 for a few minutes. Let's say 3 minutes. Okay, so for question 4, get my pen up, there it is. So question 4, you should see you've got a function here, x minus 3 is inside another function. And the function it's inside is g. So g inside f. This is your g function here, x minus 3. And you can see that inside f. That would be x cubed. And you can check that yourself, fg. Put your g inside f. So this will go inside this. So you can see it's correct now. So that would be x minus 3 inside x cubed. So this is the correct answer here. These are your 2 functions. Okay, you'll see it in the homework sheet when you get that. So in question 5, we've got a g function here. So check you're getting this right. Inside f. Your g function is here. And we're going to put it inside f. So that would go there. So f gx is 3x squared plus 1 minus 5. So 3x squared plus 3 minus 5, 3x squared minus 2 there for your answer, okay? So that's your composite, G into F. Just remember, it's always the second one into the first one. Like that, it's always done that way. We never do it any other way. Right, I'll give you a few minutes on this one. Now, I'll set it up anyway. So you're going to put your G into F. This is your G function, and that is going to go into F. So this here has to be written into the top and into the bottom. Okay, so you do that. I'll give you a few minutes. FGX. Here, so take the yellow one and replace each X here and then simplify it. Okay, do that for a minute. Okay, so for question 6, we'll take our G function and put it in. So we're going to have 2x minus 1 plus 1 on the top, then 2x minus 1 minus 1. So this one's fairly straightforward because it's not a complex fraction. So this will cancel. You have 2x on 2x minus 2. We can factorize the denominator as 2x minus 1. So then the 2 will cancel here. You'll get x on x minus 1. And nothing else you can do with that. That's it. Okay, you may have forgotten to factorize here, but try to factorize where possible to simplify it a bit more. Okay, 6 is okay. 7. Okay, take a look at 7. Now what you're going to do with 7, we've got the function and we've got a G function here. When you do these problems, you need to go right into the middle first. So start in the middle. Right in the middle. And that function is G7. You see that? G7. So we know what is G already. So you calculate G7 first. Then you put that into F and you put that number back into F again. Right, you try that one and see what happens there. Okay, try question 8 for a little while. A few minutes there. Question 8, you're going to have to think a little bit about that. You may need to do some guessing and checking on question 8. So with this question, G7 should give you minus 46, correct? So put 7 into here, 3 minus 49 minus 46. So then you look at this part here. So this is telling you G7 is minus 46, like that. So the next thing you need to do is put minus 46 back into your function. And when you do that, you'll get minus 2119 for F46. And your last step, you need to put this number back into F again. So F minus 2119. And this will be your final answer here. And you'll get a big number. So take this number and put it back into your F function, right? Into F. Put that into there. Okay, and you should get minus 4490164 by your calculator for that one, okay? But on question 8, take a look at this one. You've got a composite. You've got f and f minus 9. So it looks like there's something you can do here. So I'll let you think about that for a little while. Think about this bit first. But you're going to have to do some guessing and checking here when you try to get the final answer. All right, try that one. If you've done that one, go down to question 9. That one's straightforward. You can do that. They're multiple choice questions below. Okay, try that for a while. We've got 20 minutes, so let's see if we can get them all done, mostly done. But you should try yourself first, because your homework will be similar to this. Okay, so for question 8, we want to find f minus 9 using f here. We have the function already. So f minus 9 is 2 times minus 9 plus 6 minus 18 plus 6. That's minus 12. And here it's saying that this value is going to be minus 12. So I could write that down as g minus 12 equals minus 3. So just put it back in here. So that means when you put minus 12 into one of these functions, you should get minus 3 for the answer. Okay, does anyone get an answer for that yet? Can anyone get the correct answer? Question 8. So think about that and tell me which letter do you think it is without looking in the answer key. That's why I said at this question, you need to check. When you put minus 12 into the function, you get minus 3 as the answer. So which function is gx? Anyone have an answer yet? So your input is minus 12, and the answer you get, your output is minus 3. Anyone? For example, if you check the first question, the first possible function. So if you said f(g), if gx is x on 2 minus 3, when you put minus 12 in here, we'll get minus 6 minus 3, which is minus 9. So that's wrong. We're trying to get minus 3. So this one, no. Okay, and then we try the next one. You can probably do it in your head and see which one it is anyway. But if gx was x on 3 plus 1, and your x value is minus 12, we put it in here. You get minus 4 plus 1, which is minus 3, which is correct. We got minus 3 here. So B is your answer for that one. You don't need to check anymore. They should all be wrong. So 15 minus negative 12. No, 15 minus, yeah, that would be positive. So yeah, so none of these others work. So when you're checking a multiple choice, just start from the top and go down unless you see one obviously is correct. Okay, that's question 8. Well, now you see what you've got to do here. Gx is here. And fx is there. So you have to do two composites and then subtract the number and see which one is correct here. So that one is just, you're simplifying. Okay, try that one for 5 minutes. 9 and 10 you can try. Right, do 9 and 10. They're the last two. So I'll give you 5 minutes to do them and we'll finish there. We won't do any more on composite today. I've got your homework, not marked yet. I've been busy with grade 9. So I'll get to your homework soon. If you haven't sent it, send that real quick if I didn't get your homework yet. And the new homework, I may send this topic, okay, elective again, because we've already done this. And for core, we'll start tomorrow. So I won't send core homework. I'll send this composite function homework. I can send it tomorrow actually, because we finished this today. So for question 9, let's get our functions here, gx. And we've got to put that into f. So this will go into f here. So you'll have 2, 3x plus 2 plus 3 minus this one. And then we put f into g. So take your f function and put it into g here. So you'll end up with, let's keep it like that. So 2, 3, 2x plus 3 plus 2, like that. Keep it in a big bracket because you need to subtract the whole thing. So this will be 6x plus 4 plus 3 minus 3 2s are 6x, 3 3s are 9 plus 2. So we'll have 6x plus 7 minus 6x plus 11. So 6x plus 7 minus 6x minus 11. Cancel your 6x, 7 minus 11 minus 4. So that will be A. Okay, for that one. So straightforward. It's just a basic calculation, that one. Okay, what about 10? We've got 8 minutes. So this was misnumbered, A, B, C, D, E. That should be E there. The last one. So think about this for a little bit. F inside G and simplify, okay? And this will cover everything on the homework sheet. Okay, we'll finish up this question. That will be the end. So we're going to put F into function G. So this function is going to go into function G. Yeah, that's an easy one. So G fx. So take your f function, x squared, and put it in there. So 1 minus 1 on x squared. So that's an easy one. It just pops straight up. So that didn't require any simplification or anything, okay? Because we already found it. If you don't find it, you may need to make this into one fraction. So for example, you could write x squared on x squared, which is 1, minus 1 on x squared. So you'll get x squared minus 1 on x squared. And that's not here. You see? So you could have done that, but you wouldn't have the answer. The answer just comes straight out to that one there, okay? Any questions? All okay? So we'll stop there.